Hi class, welcome back to the log functions, the section 10.5, and this is the part 2, and we're going to solve some log function equations here, and this really is the finale for this semester. I cannot believe the semester going to end just like this. Okay, so before we do that, let's do a quick review, and I wrote it out before I started the videos here. So the first things here, we said a log function and exponential. They are kind of, you can rewrite to each other, right? So in here, this A things here, this is, we call this the base here, right? And then we have several properties here. So we have the property, like if you add them, is you times it. If you minus them, is you what? You divide it, right? So you minus it, divide, you add is multiplication. Then if you have like the exponents, basically you can move the exponents to the front here. And we said the log function doesn't matter what is the base, 1 is always equal to 0. And for here we say, hey, if your log base is equal to the base of your exponential, because they are the inverse function, so it seems like you can just cancel that out. That's why it will be the R by itself here. Okay, so that's pretty cool, right? Okay, now let's take a look. We're going to this video, we're going to talk about how to solve the equations here. Okay, we're going to start with the easiest one. Then we're going to go a little bit further, a little bit, the harder here. So let's take a look at the first ones here. So we want to solve the log x here and 16 equal to negative 12. So I want to solve for x. Okay, so now in here you see the log x. So right now the base here, x is 8, right? So now you can use, and then we switch back to my exponential. So that means the x to the y. So this is a, and what is so this will be what? This will be your x here, right? And this is your y. So you switch back to the exponential. So it will be the ay. So a to the negative 2 is equal to x equal to 16. Okay, so the x equal to 16 is here. So now, in order to do that, we need to have the same base, so we can cancel here. So the x equal to the negative 2 is here. So this is x to the negative 2. So in here, 16 is 4 to the square, correct? Okay, 4 to the square. But in order to get it, I need to have the same exponent, same basis here. So I can say this is x to the negative 2. So 4 to the 2, right, is equal to 4 to the negative 1 times 2, correct? Because negative 1 times 2, this will give you, I'm sorry, so this one, so here, so this will be the, okay, so here, okay, so sorry here, this one's here is x equal to the negative 2. Okay, so here will be, I'm sorry here, where's my pen? Right, so this will be negative 2 here, right? So because in here you see negative 1 times negative 2 equal to 2. Okay, now you say, oh, okay, now I got it. So like in here, you will see here, because now you both have the what? The same exponents. Because you both have the same exponents, kind of you can cancel. That means your base has to be equal. That means x has to be equal to the 4 to the negative 1. So what is 4 to the negative 1 is 1/4, right? So the x equal to the 1/4 will be the solutions here. So you either change it to be the same base or change it to be the same exponents here. Okay, so now the next things here, let's take a look. So the next things here, let's take a look at this is the log. Okay, so the log x16, let's see here, log x16 is equal to 4/3. Okay, so log of 16 equal to 4/3 here. Okay, so we'll do the same things, right? So let's take a look here. So this is my basis, right? And what is these numbers here? This is my x's here, and this is my y's here, right? So I change it to the exponential form. So I would say this is x to the 4/3 is equal to 16th here. So now I need to make a little bit of changes here because so this is x to the 4/3, right? So it's 1/3, then this is the 4th, right? And what is the 16? I can change it to the 4th power. I know it's 2 to the 4th powers, right? Okay, now you see here, because this one and this one, they both have the same exponents. So you kind of can cancel that out. Then that means you will get the x to the 1/3 is equal to 2. So in order to get the x here, so what you need to do is here, you need to cube the x, right? So you need to cube, right? Both sides. So that means 2, I need to cube it. So that's why the x to the 1/3, this is x. 2 to the cube is what? Is x to the 8 here, right? That's how do we get the values here. Okay, right? So by using that, you switch back and forth between the log functions and the exponential. Then you either one have the same base or you have some exponents. Then you can cancel out. Okay, let's take a look at our next examples here. Okay, the next examples here is this is log 2x minus log 2x plus 1 is equal to -1. Okay, so the first things you say, oh, I recognize log minus log. What is log minus log? By using my log property. So this is log 2, x over x plus 1, correct? Okay, now you say, oh, okay, so now this is my A, right? So this is my x. So we do the same tricks, right? And this is my y's here. So we do the same tricks, like now we change it to exponential. So that means the x, so it's the x plus 1 is equal to 2 to the y, so it's 1/2, right? So 2 to the 1/2 here, so this will be x to the x plus 1 is equal to 1/2, correct? Okay. And then now, in order to solve it, I can use the cross product. So I say, okay, I cross product it. Then I will get 2x is equal to the x plus 1. Then in order to solve this one here, I will minus x both sides. So I will get x is equal to 1. So that will be my solutions here. Okay, that's pretty easy. So this one is not too bad, right? Okay, so let's see here. The next one's here. Okay, so let's take a look at our next examples here. So the next example here, it will be This one here is a natural log x plus natural log 2x equal to 5. And don't get nervous. So you see a natural log. That's just another log functions, right? So immediately you know log x plus. So what's that mean? Oh, that means I can do the natural log x times 2x is equal to 5. That means it's a natural log 2x squared equal to 5 here. Then you say, how do I do this ones here? So you remember e and the natural log. So the natural log is really a base with what? With base with e's, right? So this one you can rewrite like this. Then you will say, oh, now I see this is my base. This is a, and this is my x, and this is my what? My y's here, right? So now I can write it. So I will say the 2x squared, right, is equal to the ey, so e to the 5th, right? Now solve for x, so divided by 2, divided by 2. So x squared is equal to e to the 5th divided by 2. So what is x here? X could be the square roots of the e to the 5 over 2, or x is equal to the negative e to the 5 over 2. But I know the natural log cannot have negative, the inside layer domains here. So this one is not going to work. So the solution for this one will be just x equal to the e to the 5th over to the square roots. All right. Okay, so this one is not too bad, right? So you just need to recognize the natural log, right? So it's the base is log equal to 10. Or another way you can see here, because we know the natural log and the e, they are inverse functions, so they cancel each other out. So instead of looking this one, then you can do this. You can say, hey, let's take e both sides. So that means you will have e natural log 2x squared is equal to e to the 5th. And then you will say, oh, e and the natural log cancel because they are the inverse function. So that's how do you get the 2x squared equal to e to the 5th. So that's just the same we got here. Then you can try to solve it this way. So either one will work, right? So if you just want to take e both sides, that's kind of neat also, right? You can do that. Okay, let's take a look at one last problem here. This problem also show you a different techniques here. Okay, so here I have these ones here. So this is a 5x plus 4 equal 8x. So you said, oh boy, they have a different bases here. And they have a different base. Well, what I need to do, I cannot set exponents the same. So the tricks here, or the technique here, we should say technique, not tricks here. I can take a log functions, both sides. You can take any type of the log. Of course, for the simple and the typical, we like to take the natural log. Doesn't matter, you can take the common log or any other log, right? So you can take the log both sides. So in this example, we will take natural log of both sides. Like I said, does not matter. You can take the log with a base 100 or log with a base 2, doesn't matter. So in here, we say, okay, let's take it. So this is my equations, right? X plus 4 equal to 8x here. So in here, we say, okay, now let's take a natural log of both sides. That means I'm taking the natural in here. this is the natural log, both sides here, right? Okay, now I can use the log function property, so I can move these exponents, and this is the exponents to the front here. So that means that's the property number 3, right? So I have x plus 4. I can move the whole exponents in the front. So now what is left inside is natural log 5, right? Then these ones here, I can move the x to the front. So here I have natural log 8 here. So far, so good. Okay, now I distributed it. Okay, and I'm doing the distributed. So now I will have here x to the natural log 5 plus 4 to the natural log 5 is equal to the x, the natural log 8. I'm trying to solve for x's, right? So I minus x natural log 5 minus x natural log 5 on both sides here. So if I do that, this one cancel. So my left-hand side, I have 4 natural log 5. Then in here, I have x here. This is natural log 8 minus natural log 5 here. Then, in order to solve it, I can divide by natural log 8 minus natural log 5 on both sides here. Okay, so that's what x is. X will be equal to the 4 natural log 5 natural log 8 minus natural log 5. Of course, if you want to combine the one more step, you can say this is 4 natural log 5 natural log 8 over 5, right? Because it's a minus is divide. So that will be your value of x here. So you can take the natural log of both sides or any other log both sides and try to solve it. I think probably your math lab would be okay if you just leave like the answer like this, or you might want you to combine, so you can try both here. Okay. Well, that's it. That's the section 10.5. It's not too bad, right? So it's a good log function and it's a very popular function, especially if you take the 1325. The log function, exponential function, you definitely will deal with it. All right. So, okay, that's it. So the remaining of this semester, I think make sure to review your, your exam 4 review. And also like your exam 4 review also make sure like for the final exams I will send out the review, and so you need to know the date and time to take it, right? So make sure you continue to work hard. You guys doing great. I'm very proud of you guys. All right, so nice talk to you, and hope if you have any question, feel free to send me an email. Okay, bye.